Alright, so to finish off this question here, we need to identify the characteristics of the graph. So what we'll be looking at is the domain, the range, and what happens maybe as x and y, as they approach those asymptotes that we talked about in the last video there. Alright, so to start off, so see here, let's look at the domain. So what is our domain of this graph? So as always, you start off with a fancy bracket, x, such that, and look at your x values. Can x be everything? And so you guys notice here there is an x, or there is an asymptote here. So x can be anything except for 3. So what we'd say is x cannot equal to 3, where x is an element of all real numbers. Then looking at our range, and this is going to go along the same lines here. So we have y such that, and if you remember last video, I talked about there is this line here that y cannot cross. And if you guys remember what that one there is, it is y cannot equal 2, where y is an element of all real numbers. So that means that there is a horizontal asymptote at y is equal to 2. Alright. And just to talk about what happens at, as we're approaching these asymptotes. So what we can say here is that as x approaches 3, what we're going to say is that the absolute value of y becomes very large. Alright, so I'm going to scroll up here. So as x approaches 3, the absolute value of y becomes very large. So let's look at this. So, and remember, your absolute value is, I guess, the positive distance, or it's a positive value, whether it's positive or negative. So here, if you look, going from left to right here, so this first little bit of the graph, it does keep decreasing, but that absolute value make that positive. So go from a 3 to 4 to 5, and eventually it'll go to negative infinity, which the absolute value of that is infinity. And same with the other graph. So as it's approaching 3, so going from right to left here, it's going to keep going up and up and up, but it'll never touch 3, but it'll keep going up to infinity, and it will never ever touch 3. So that's where we say that the absolute value of y becomes very large. Alright, so if you guys can take a guess here, what we're going to say for our next one here, what about, I'm just going to erase this part here. So I think, what are we going to say about as y approaches 2? Alright, so what we're going to say here is that as y approaches 2, the absolute value of x becomes very large. Okay, so I'm just going to scroll back up again. So looking at that graph again. So as our graph is approaching this line here, I'll maybe do this one in a different color here. So as it's approaching this, oh wow, my shaky hand today. But as it's approaching the sum y is equal to 2, your x value here is going to become very large. So looking from this one here, we're going to be looking from this first part of the graph, and we're going to be moving left. So as you notice, it's going to keep approaching 2, and as it's approaching 2, those x values are going to keep getting bigger, and that's that absolute value there. So go to negative 10, or your absolute value there is 10, and same with that second part there. So as you're moving closer to 2 there, if I can find my little cursor, okay. So as we're approaching 2, our x values become increasingly larger. So that one's nice because you don't have to apply the absolute value function. But with this first part here, you notice that it keeps heading towards those negative numbers, but if you take the absolute value, then it makes them big. Okay? So now let's move on to question number 2. So that kind of talks about the characteristics of the graph. So kind of looked at the domain, the range, and what happens to those x and y values as they're approaching those asymptotes. Okay? Alright, so here in this question, we're given some sort of function, and here we need to sketch the graph. And also we need to identify any asymptotes and intercepts. And for this one, I definitely encourage you guys to use your graphing calculator. or if you guys feel comfortable with that. But one thing that we need to do that I want to cover with you guys first is that this function here that we're given here is not in the form y is equal to a over x minus h plus k. So it's not in that form that we learned where we can easily see those parameters. So what we can do though is that we can rewrite y is equal to 4x plus 2, divide that by x minus 1. We can rewrite this function to look like, or I guess to put it into our standard form. So what we're going to do is we're going to manipulate our equation, or our little fraction there, and just keep in mind that every time we do this, it's still an equivalent form. We're just going to rewrite it. So what we're going to do here is, I'm just going to rewrite y is equal to 4x plus 2, divide that by x minus 1. Now, I'm going to give you this hint here, and it might not make sense at first, but as we go through the example, you're going to see how actually nicely this works. But what we want to do is, we want this top here, we want to be able to take out a factor of x minus 1. And so what's going to happen is that we're going to be able to split up this fraction, then our x minus 1 factors will be able to cancel out, and that's going to give us our k value. Now that might not make a lot of sense at first, but let's go through this example, and hopefully it'll make more sense, and you guys will get some more practice when you guys do your homework. So, but this one, doing this is kind of an important step so you can see those parameters, okay? So first what we're going to do is, how do we get 4x plus 2? How can we make that look like x minus 1? So what we're going to do is, we're going to take 4x, and when we're thinking about this, we need to separate this 4 and x, because we need x minus 1. So what we're going to do is, we're going to rewrite, we're going to have minus 4, so that way you take out that common factor 4 and you'll have x minus 1. But we want this to be in the equivalent fraction, so you need to add 4 afterwards. So that way this would still be 4x, this would cancel out, and then we'd have plus 2. Divide that by x minus 1. Then from there we're going to factor it. So we're going to group our first little, I call them little group of guys. And so you have to ask yourself, what common factor can you take out? So here we have 4x minus 4. You can take out a common factor of 4. So we have 4 times x minus 1. Then we can group these two guys together. And what we get is just plus 6. Or we just simplify it. Write that all over x minus 1. And then what we can do now is that using our, what we know about fractions, is that we can rewrite our numerator. We can rewrite this as 2 fractions with our first fraction will be our first part of our numerator, and then our second one will be 6 over x minus 1. So remember how we can split up a fraction? We can't do that with the denominator, but we can absolutely do that with our numerator. So we have y is equal to 4 times x minus 1 over x minus 1 plus 6 over x minus 1. Then from here you're going to simplify, so we can actually cancel out these common factors of x minus 1, and we get y is equal to 4 plus 6 over x minus 1. Then all we have to do here from here on out is just rearrange. Let's flip these two around. So y is equal to 6 over x minus 1 plus 4. And if you notice, this here is in our standard form, so here we have that, here we can easily see those parameters. And if you guys do this, check this, this new, I guess in our standard form, check this with your original one by putting both of them into your calculator, and they should overlap, and you should see that they're the exact same thing. But this way, in this form, we can see that we have an a factor of 6, we have a k of 4, we have an h of positive 1, just that way you guys can see those parameters, okay? So from here, what I'm going to ask you to do is, let's put 6 over x minus 1 plus 4. Let's put this into our calculators, and then let's graph that. And then you guys will we'll answer those last few questions based on those graphs, okay? So I'm just pause the video now, put that into your calculators, and I'm going to take a screenshot of mine so we can move on to these move on to the question, okay? Alright, so hopefully you guys had a good chance there to draw out your graph. One thing that I can do for you guys, if you like, I can quickly write out here a table of values, and this is approximately where you should be along the lines of, your graphing calculators will give you a table of values, but if you guys want to see what we should be getting around there, we should have -4 and 2.8, -3 and 2.5, -2 and 2, -1, and 1. Then we have 0 and negative 2, 1 and undefined, 2 and 10, 3 and 7, and it goes on and on and on. But if you guys want to, there's some table values there for you. But here, I have the graph here. It's a little bit harder to see that one. My graphing calculator, I can't really zoom up on the, or I guess make the grid a little bit looking, or make it look a little bit nicer. But so there's a kind of a little rough sketch of what it is. So you guys should be able to see this in your graphing calculators, and you guys can open up your table values to actually look at some of the values that we'll see when we're doing this, okay? So here's our graph. Hopefully you guys had a chance to sketch it in. And so now what we need to talk about is any asymptotes and any intercepts. So first of all, let's talk about our vertical asymptote. I'm just going to label that VA. So your vertical asymptote is when we have our x value. And if you guys see that from the graph, that is awesome, but we can also do this algebraically. So your vertical asymptote, that is when we're looking at our denominator of our fractions. So that's when we had 6 over x minus 1. So what value for x will make our denominator 0? So set that equal to 0. And what we have is that x is equal to 1. That right there is our vertical asymptote. So then moving on to our horizontal asymptote. This one, if you guys remember, this one actually we don't need to do any more calculations up to this point. So actually what it is, if you guys remember from our first video, your horizontal asymptote is your k value there. If you guys remember, your k was equal to 4. So that means our horizontal asymptote will be is that y is equal to 4. Okay? So for your horizontal asymptote, just look at your k value. For vertical asymptote, when does that denominator equal to 0? Okay? So then we need to find our intercepts. So let's look at our x-intercept first. So your x-intercept there for you guys, if you guys remember, that is where we let y equal to 0. If you guys can't see that from your graph, we can always do this algebraically. So let's let y equal 0. So we have 0 is equal to, and that would be 4 plus 6 over x minus 1, or we had it the other way around, sorry. So what we're going to do is we're going to move 4 to the other side. So we have negative 4 is equal to x over, or 6 over x minus 1. Just going to scroll on down here a little bit. Then to get rid of this denominator, let's multiply both sides by x minus 1. So we have negative 4x plus 4. So we negative 4 times x, negative 4 times negative 1. That there is equal to 6. When you multiply both sides, it cancels out. And then we'll move our 4 to the other side. So we have negative 4x is equal to, that'd be 6 minus 4 is 2. Then to divide, or then we'll divide to get the x by itself. So we have x is equal to negative 1/2. So our x-intercept, if you want to leave it as x is equal to this, or you can write it as your coordinates, you'd have negative 1/2 and 0. What you can do is check it either with using your graph, or you can also look at your table values in your graphing calculator. You should be able to look at smaller values, so you guys can manipulate that to work with it. So yeah, so there we go. So then our next one here is y is equal to, or is our y-intercept. And this is where we let x equal to 0. So here we have y is equal to 4 plus 6 over 0 minus 1. Y is equal to 4, that'd be negative 1. So 6 divided by negative 1 is just negative 6. Then we have that y is equal to negative 2. So you could either leave it in this form, or you could write it as a coordinates. We have 0 and negative 2. Alright. And now actually what you guys can do is you see this up here in our table values. So that should hopefully give you a little key note there that you did your math right there. Okay. So that's it for that question. So now you guys can get started on your homework. And so, you know, the biggest thing here I'm just going to point out is it's going to be a lot easier if you create or change this or manipulate it so that it's in your standard form, and it'll help you see you know, where your vertical asymptote is, or where your stretches are, where your translations are. So it'll make life a lot easier. So there's lots of practice there in your homework. So you guys can go ahead and get started.